Good day, seniors. This video lesson is about conditional probability. Conditional probability measures the probability of an event A given that another event B has happened, or simply the probability of A given B. And it's mathematically written as P, open close A, then the bar there, B. So this is read P, probability of A given B. So basically when you see this bar here, you relate it as P of A given, so that's given B. Now, for any two events A and B, the conditional probability of A given that B has occurred is given by. So again, P of A given B equals the probability of the intersection of the two events over the probability of B. Now, if we want to reverse it, following the same formula, the conditional probability of B given that A has occurred or happened. So this time it's P of B given A is equal to P of the intersection of B and A over P of A. So basically from these two, we can create another equation. Since you see the numerators are the same for both. Now, what I mean is in this one, see we can solve for P of A intersection B there, and it's equal to P of A given B bar, A given B, it's bar, times the probability of B. In the second formula, the probability of the intersection B intersection A is of course equal to this times the denominator is just cross multiply, right? So P of B given A times P of A. Now, since these two are basically the same, A intersection B is the same as B intersection A, right? So these two are equal. So P of A given B times PB is equal to P of B given A times P of A. So there, basically you have these three formulas, including this, the one that's derived from the two. So just showing you the relationship. Now let's have some problems. A fair dice rolled once. What's the probability that the number obtained is less than 5, given that an odd number is rolled? So you see the word given that. So that's where your bar is. So let's just say that the probability of A is that the number obtained is less than 5 from a die, from a fair die. And let's say the probability of B is that the number obtained is odd. Okay, so what we are asked here is the probability that the number obtained is 5, given that an odd number is rolled. It's basically P of A given B. So again, you see is how to read this. Probability of A given B. So probability of less than 5 given that it's odd. So you know that this should be the probability of the intersection of the two events A, B over the probability of B in the denominator. So basically, the numerator is the intersection of the two events. So what are the numbers that's less than 5 and odd? So there are only two. Basically, it's from, the dice 1, 2, 3, 4, 5, 6. Number less than 5 and it's odd, so it's simply 1 and 3. So there are only two. Over the total, of course, probability is 6. And then probability that it's B, it's odd. So there are how many odd numbers here? So including 5 this time. So there are 3 odd numbers over 6. So basically the answer here is 2/3. So that's it. Let's have another example, but I'll erase this first for the second example. This is a very short video, by the way, so I'll just take it slow. About this, the probabilities of a student passing math, English, and both math and English are 40%, 65%, and 25% respectively. What is the probability that he will pass math, given that he also passes English? Then there's a next question. What's the probability that the student will pass English, given that he passes math also. So you're familiar with this, since these are basically Venn diagram, can be illustrated by Venn diagram. So let's say you have your math and then English, right? So if the probability that both math and English would be 20%, so this respectively, so that must be the value inside 20%. So that's 20. Okay, let me create a bigger one. So that's this is math, this is English. So probability both math and English is 20%. Citing the problem that the probability that passes math 40%. So we have 20 here, so this must be 20 also, so that the whole thing here, the whole of this is 40%. So English is 65%, so the whole of this will be 65%. So this must be 45% only. So 45 plus 20 give you 65. Now, the first question, the probability he will pass math given that he passes English. So probability that math given English. So that's it, basically. So this is equal to probability of M intersection E over probability of E. Right? So this is M intersection E, that's the value in the middle, so 20%. And then the probability that passes English, it's of course English is 65%. Okay. So this is 20 over 65%. So this is divided, let's answer in fraction form. So 20 divided by the 5 that will be 4 over 65 divided by 5, that will be 13. So 4 over 30 in fraction. You can convert this into percent. Of course, I don't have a calculator with me. So next, what's the probability that student will pass English given that he passes math also? So this time, it's the reverse. English given math. So this, of course, following the formula again, English intersection math over probability of math. So this would be English intersection math, still 20%. Then probability of math, it's 40%. So basically, you know, this is 1/2. And it's easy to convert to decimal value, yes, 50%. So that's it. Let's have another last example. So we have here a table, this time a table. So in this table, this is basically a survey of how many in total, 290. Of those 290 people, 90 are professional, 200 are sub-professional, and then again categorized into male and female, you see here in the table. Now let's see the first question. What is the probability that the person picked is a female professional? So it's a simple probability, female professional. Female professional. So where is it? So female here, and then professional here. So basically 50. So it's 50 over, of course, the total 290. Again, let's just write our answer in fractions. So you have 5 over 29. That's it. Now, let's have the next question, number 2. What is the probability that the person selected? So, a person will be selected of 290. The person selected is a professional, given that the person is male. Now you see again the word given that, right? So that must be probability for number 2. That the person selected is a professional. So just denote F for professional. Yes, F. Professional. F, right, okay. Professional, given that the person is male. So given that. So again, the bar then, male. So you have here, we may confuse F with female, so let's stick it as P. F, sub F, professional. Alright. So this is the probability, again, the intersection of the two. Professional, intersection M, over the probability that it is male. So again, this would be, what's the intersection of the two, professional and male? So where's that? Professional and male. So basically that's 40, right? Over 290 the total, that's the probability that you have both male and professional there. In the denominator, the probability is male. So male, the total number of males is this, 160, right? So that's 160 over 290. So this cancels out. That's 40 over 160. That's 1/4. So the probability is 1/4. Again, if you want 2%, it's equal to 25%. Right? Then the last problem, last question, number 3, just put it here. Okay, number 3. What is the probability that the person selected is female given that she is a sub-professional? So again, the word given that. So just divide it into 2. The first one is female. So female. Now we're using F for female. Given that, so that means the bar, your bar. Given that she is a sub-professional. So let's denote it as sub-professional, SP. Sub-prof. Then, so this is your conditional probability. So you have here the intersection in the numerator, female and sub-professional, over the denominator, which is of course sub-professional. So that it's very easy. So you have for the numerator, the probability it's a female and sub-professional, so it should be 80 over the total 290. So then for the sub-professional, so you have to get this, the total sub-professional 200 over 290. So this cancels out. Then 80 over 200, it's 8 over 20. Simplifying 4 over 10. Finally, it's 2 over 5. Simplified. Or, again in percent, is equivalent to 40%. That's it, seniors. The end of the 3 lessons during the holidays. Good day.